Alright everyone, you might notice that videos look a little bit different. There's two reasons for this. One is this is going to look a lot more like your guided notes, and so I can scroll up, scroll down. It's a lot easier to go back to where we last left off. And the other reason is that I'm able to write in more space using this method than the others. I know that the video quality isn't quite as good, but hopefully you'll bear with me, and if everything should still be really easy to read. I just tested it on my phone. It should be just fine. If you're having issues, please be in touch. So we're going to start. We're going to talk about solving with rational numbers today, so make sure your packet is open to that. If you don't have your packet, you've lost it, it's at mom's house or something else, feel free to print out this sheet. If you've lost the entire packet completely, please be in touch. I can print off some things for you. Notice how we're starting with section 6 from chapter 3. Now, this is because I assume, and the evidence on the prior learning bears this out, is that the vast majority of you already know how to do things like add, subtract, multiply, and divide with rational numbers. Rational numbers, as we're going to define right here, are numbers that can be written as a fraction. And if you are one of those students who maybe, I don't remember how to add and subtract, I don't remember how to divide with fractions, I strongly recommend that you do some review in sections 3.1 through 3.5. You can still do odd problems. Check your answers in the back of the book. If you would like help with those sections, please make it an appointment at the top of the classwork tab, or you can just copy and paste the link that's in the banner. If you just click on that, and it'll expand out and it'll show you the link there. So those are all options for you. Now, when we're going to talk about solving, you can absolutely use some of those skills. So for instance here, if we look at this problem number 1, we notice we have fractions that are being added. Now, as most of you do recall, if I ever have added or subtracted fractions, that means that we need a common denominator. Now, the common denominator means that we have the same number on the bottom of all of the fractions here. Now, with our common denominator, we just want to look at the numbers that we do have in the bottom of our fractions and ask ourselves, what number do they all multiply to easily? So if we have 3, 9, and 6, those would all multiply to 18. So 18 would be our common denominator in this case. And we just go through and we multiply. So 3, in order to get to 18, we need to be times 6. And we do the same thing to the top of the fraction. Now remember, this only works with multiplying. You can't add 6 to both. Times 6, the next fraction, if I wanted to equal 18, would be times 2. And the last one would be times 3. Now, we have all of our fractions with the denominator of 18. So 12n over 18 plus 14 over 18 equals 3 over 18. Now, certainly a common denominator makes it easier to add and subtract. If I wanted to cancel out this, subtract it over, you absolutely can. But I want to show you a fun trick that you can do as well. I'm going to multiply everything by 18. Now remember, as long as you do the same multiplication to all the terms, it's just fine. You're not breaking any rules. And the nice thing is that since it's an equation, if I multiply on both sides, I then get to simplify. 18 over 18, 18 over 18, 18 over 18, and my common denominator has simplified the entire equation to 12n plus 14 equals 3. Now, one really important thing to remember is you can only do this with equations. If it's a regular fraction, you can't do this. You have to have the opposite sides of the equation, so you have to have an equal sign in the middle. But once you do that, very nice, easy to solve problem. 12n plus 14 equals 3. Subtract 14 on each side. 14 cancels out. We end up with 12n. 3 minus 14 is negative 11. I will divide by 12. And we end up with our final answer. N is equal to -11/12. And you can absolutely just leave it as a fraction. Don't worry about, sorry about that, don't worry about changing that into a decimal. It's not going to work nice. So again, the strategy that we're using here, and the nice thing with this strategy is it works for things that are already looking like fractions, but remember, rational numbers are numbers that can be written as a fraction at all. So if I'm looking at here where I have a whole number, -3, a decimal, 0.6, and a mixed number, 4.5, these are all rational, and if we turn them into fractions, we can use this same strategy. So -3x as a fraction would be -3/1x plus 6/10. You could simplify that to 3/5 if you want, but we're going to use a common denominator, so we're going to simplify in a little bit anyway. And this would be 9/2. Again, if you want to review these sorts of skills I'm using, please do. And please reach out if you want any help with that. Then I'm going to look at my denominators here. I've got 1, 10, and 2, so my common denominator is 10. In this case, I can just multiply by 10. This strategy also works. Just multiply by the common denominator. And then you have -30/1, because the whole number multiplies into the numerator, plus 60/10 equals 90/2. And then again, the whole thing will simplify. -30x plus 6 is equal to 45. Now from there, it's a straightforward solving problem. We subtract 6 on both sides, and we end up with -30x is equal to 39. Divide by -30 to get the variable by itself, because remember, that's always our goal with our solve problem. And we end up with x is equal to, and you can just leave this as a fraction, but we're not going to leave it as the fraction 39/30 because we can simplify this fraction. Both those numbers are divisible by 3. 39 becomes 13/10. Again, you can leave it like this if you want to simplify it, or rewrite it as a decimal or a mixed number, that's fine. Now, for those of you who just feel ready, can move on. If you want to see another example, look at the PDF that's attached, and there's an example of how to do a problem with all decimals. If you have any questions, please be in touch, and I look forward to hearing from you. Have a great day.